Okay everyone, welcome back to another Maths Challenge question. I've got an interesting looking question here today, so let's have a read of it together. So the numbers x, y and z satisfy these weird equations. What is the mean of x, y and z? Cool, so have a go at this by yourself, pause the video, then you can unpause it and we'll try and work it out together. Cool, alright, let's get started. So, interesting question. We've sort of got simultaneous equations. The question is asking us, what is the mean of x, y, and z? So I think an obvious starting point is to write a mathematical expression for the mean of x, y, and z. And that's just clearly x plus y plus z all over the number of terms, which is 3. Cool. So an interesting thing is it's not asking me to find x, y, and z. It just wants this expression. So we need to think, how are we going to use these equations to get this expression by itself? Interesting question. Let's have a little think. I'm just going to rewrite those equations first. So we've got 9x plus 3y minus 5z equals minus 4. And we've got 5x plus 2y minus 2z equals 13. Okay, I don't really know where to start. I think I'm just going to add the equations together and subtract the equations together, and hopefully I get something useful from it. So let's just add the equations together. So if I add the equations, I add the x values, the y values, and the z values, and it will equal the sum of the constants. Cool. So we would have 14x plus 3y plus 2y, which is 5y, and minus 5z minus 2z is minus 7z. Add the constants, we get 13 minus 4, which is 9. Okay, this is not that useful. Ideally, what I'm looking for is that the coefficients of x, y, and z are the same, so I can divide both sides by that number and get something close to this. So that wasn't that useful. Okay, what happens if instead I subtract this from this? What would I get then? Well, I would get 4x plus y, be careful here, minus 5 minus minus 2, that's going to be minus 3z. And then minus 4 minus 13 is minus 17. And again, I don't get anything that useful because the coefficients are all different from each other. Okay, so I'm a bit stuck and wondering where really should I go next from here. I need to think of some sort of eureka light bulb moment to help me further with this question. Okay, what happens when we do this equation minus this equation? We would get 10x plus 4y and then minus 7 minus minus 3, which is minus 4z. Okay, that gets 26. So we're a bit closer because now we've got 4 and minus 4, so the signs are wrong. But that is a bit more helpful at least. Okay, nice. And now what happens when we do this equation minus this equation? We would get x plus y, and then minus 4 minus minus 5 is going to be plus 1z. And then we've got 26 minus minus 4, which is 30. Cool. So therefore, x plus y plus z all over 3 is going to be 10. And that is our answer. Ha, okay. So I kind of just did that by trial and error, right? I sort of added these equations together and subtracted the equations. Let's have a think back at what I actually did there. So I started with adding the equations to get this. And then I subtracted this equation from this equation to get this. I then subtracted this from this. And then I subtracted this equation from this equation. Okay, let's actually have a look at what I did there. So I had equation 1 and I had equation 2. And first I did equation 1 plus equation 2. And then I did equation 1 minus equation 2. Then I did 1 minus 2. No, I did 1 plus 2. Then I minused 1 minus 2. So I had 2 lots of equation 2. And then here I did 2 lots of equation 2 minus equation 1. Okay. So I realized what I did. I multiplied equation 2 by 2 on both sides to get this. Then I subtracted equation 1 from it to end up with x plus y plus z by itself. Okay, so the key thing there was, how would we add and subtract these equations together in order to get x plus y plus z? And I sort of did it by trial and error. I guess the key thing is, if you look back at these equations and look at the coefficients, if you multiply each one by 2, you get a number that is 1 more than the coefficients here. For example, 5 times 2 is 10, which is 1 more than 9. 2 times 2 is 4, which is 1 more than 3. And minus 2 times 2 is minus 4, which is 1 more than minus 5. So you need to sort of spot that pattern, or do it by trial and error, in order to then get x plus y plus z by itself, like we did. Right, cool. Fun question. I hope you enjoyed that one. It's one of those questions where it's like, you don't really know how to do the question, but you just need to get started, go with the flow, and sort of hope for the best. And patterns and things will arise as you go along. The worst sort of questions are like when you can't really do any work because you don't even know where to start. But in this case, we had these equations, so we thought, okay, let's just have a play around with them and sort of hope for the best. And things worked out well for us. Cool. I hope you guys enjoyed that video. If you want me to do some specific types of questions or specific types of exams, let me know in the comments and I'll have a read of those. Alright, I hope you guys enjoyed the video. I'll see you in the next one. Bye bye.